Hello, good day. I'm Dr. Roslyn Oluwaseun Ogundokun, a postdoc research fellow in the Department of Computer Systems Engineering, Sewanee University of Technology, Victoria, South Africa, a lecturer in the Department of Computer Science, Landmark University, Umuaran, Nigeria. I'm going to be presenting our article titled Benchmarking Classic Machine Learning Models for Diabetes Diagnosis, a performance evaluation framework using confusion metrics and ROC analysis. These are my presentation outline from introduction through objective and motivation, literature review, materials, proposed method, result, discussion, conclusion and future works, then references. Introduction. Rising global prevalence of database has been discovered over the years and still being discovered presently. And it was discovered that there is need for early diagnosis to prevent mortality and critical diabetes condition. Now, the role of machine learning in clinical diagnostics is very essential and important, but it has been discovered that we have limited current diagnostic method, and this led to us conducting this research. The objective of this research is to benchmark 5 classic machine learning models for diabetes diagnosis, and the motivation behind this study is the need for interpretable and reproducible diagnostic methods, the gap in comparative performance analysis using consistent criteria. These are some of the related works that were reviewed, and it was discovered that most of the related work didn't compare their study with the existing machine learning models. Then some, they only use maybe accuracy for their performance. They didn't use ROC, they didn't use confusion metrics, and so on. So the data set that was used for this study is the PIMA India data set, and its feature includes glucose, BMI, age, insulin, and so on. And it was discovered that the data set is a binary class data set, which include the diabetic class and also the non-diabetic class. The class distribution is 35% diabetic and 65% non-diabetic. Then the pre-processing phase, the following activities were conducted. 1, the handling of the missing values were conducted because there are some values that were missing in the Excel. We had to handle it so that it won't affect the training of the model. Then feature standardization was also conducted. Then label encoding was also done on the data set. And then while all this preprocessing were completed, the data set was splitted using the stratified method into 80-20. 80% for training, 20% for testing. And then we introduced the use of grid search hyperparameter tuning with 5-fold CV. Then these are the model pipeline for the proposed study. As seen in the diagram, the diabetes dataset was inputted into the system, the processing was conducted, and then the dataset was splitted into 80-20 using the stratified method. And we used 5 models, that's 5 machine learning models, which include logistic regression, decision tree, KNN, that is K nearest neighbor, naive Bayes, and SVM. And then after each model were trained, they were evaluated using the confusion metrics and ROC curve. Then this is the hyperparameter tuning that was done on each of the model. So I said earlier that the hyperparameter tuning, the method that was used for that is grid search, and these were the final or the best hyperparameter that were used for the model training eventually. So this is the results that were gotten from the training of the model. This is the confusion metrics of each of the models that were used for the training in this study. And then these are the ROC curve of each of the models that were used in this study for training, the 5 models. Then this is a performance table. We try to evaluate the performance of each of the models that were used for training in this study. And it was discovered that logistic regression and SVM had over 70% accuracy. But checking through this table, we see that SVM performed best in terms of accuracy compared to logistic regression, because the accuracy of SVM was 0.758851, which is far better compared to the logistic regression accuracy of 0.7453. But in terms of precision, logistic regression had the best results, which was 0.7366 in terms of precision, followed by SVM with 0.7236, and then naive bias with 0.7231. So in essence, it was discovered that logistic regression and SVM were performing almost close to each other, but in most of the results, the SVM performed better than logistic regression. For instance, in terms of accuracy, in terms of recall, the SVM performed better than logistic regression. Now, as form of discussion, SVM and logistic regression showed the highest AUC and balance metrics. So naive Bayes had the highest recall suitable for screening. KNN and decision tree struggled with accuracy and false negative. So the model choice should be based on the performance and interpretability. That is the practical implication of this model training for this study. Now, in conclusion, the classic machine learning models achieve 70 to 80% accuracy. Logistic regression and SVM offered robust, interpretable baseline performance. So in the future, we are planning to explore the assembled model. That is, after these models were implemented individually, just like we have in this study, we want to assemble their results together, and then we use that to compare with the individual baseline model. And then we plan to use deep models like CNN, pre-trained models, and so on. Then in the future, we plan to extend the features like using biomarker for validation of the data set. And then we plan to incorporate explainable AI like using Shape, Lime, and so on. Thank you. These are my references, some of the references that were used in this study. Thank you for listening. I remain Dr. Oslin Oluwaseun, and then this is my contact number and my email address. Thank you so much. Bye.